All right, today we're going to dive into a really fascinating piece of tech. It's something that basically gives heavy machinery, well, a mind of its own. It's the critical bridge between pure software and actual, real world physical work.
So let me start with a question that, on the surface, just feels wrong. I mean, we're all taught to see a 100% charge as the goal, right? It's a good thing. But what if, in some really important cases, hitting that number was actually a sign of incredible, total waste?
Take a look at this screen. In the world of remote, off-grid power, we're talking a farm in the middle of nowhere or a clinic running purely on solar, this screen is actually terrible news. See, it means that once that battery hits 100%, every bit of energy generated by the sun for the rest of the day, it's just thrown away. Poof. It has absolutely nowhere to go.
And this is what we're calling the paradox of wasted power. It's this completely counterintuitive situation where reaching your system's absolute maximum capacity actually leads to maximum waste. Your best is just not good enough. So what's actually happening here? Well, in what's called an island mode setup, the solar inverter's #1 job is to protect the battery. So the second it's full, the inverter just clips production. It stops taking in power. And all that potential solar energy for the rest of the afternoon, it's just lost. For a critical operation, that is a huge, huge waste of perfectly good, free, clean energy. So, how do you fix this? Well, you need a way to build a bridge. You need something that lets smart digital logic actually talk to and control heavy physical hardware. You've got to connect the digital brain to the physical brawn. And that bridge is called the industrial Foreman. Now, this is a software agent, but, and this is key, it doesn't live on some distant cloud server. It lives right there, on site, on what we call the edge, making real-time decisions for the actual equipment it's plugged into. You know, this quote just hits the nail on the head. You can have the most brilliant, sophisticated software in the world, but if it has no way to actually communicate with the hardware it's supposed to control, it's completely useless.
And this little guy is how the Foreman actually talks to the machine. It uses this special, rugged, industrial-grade adapter. Think of it like a universal translator. It lets a modern computer speak RS-485, which is the old-school language used by a ton of industrial hardware. This simple-looking cable is the absolute key to giving older, dumber equipment a brand new brain.
So how does this agent actually work? Well, this is where it gets really cool. It's designed with two very distinct missions. It's almost like it has two personalities, depending on what job you give it.
On one hand, it can be a grid balancer for stationary places, like those farms and clinics we mentioned. And on the other hand, it can act as a supply chain diplomat for a whole mobile fleet of trucks. It's the same core brain, just applied to two totally different problems.
Okay, let's start with the grid balancer. This is the personality that directly solves that whole paradox of wasted energy we talked about right at the beginning. So here's how it works in action. The Foreman is constantly watching the battery level and even checking the weather forecast. When it sees the battery is getting close to full, let's say it hits 98%, and it knows the sun is still blazing, it takes action. It instantly triggers a relay, a little switch, that diverts all that excess power to a secondary task, maybe heating a big water tank or running a water pump. The result? It's beautiful. 100% energy utilization. Absolutely zero waste. And the logic behind this is just so simple, but it's incredibly powerful. The agent sees high solar input. It asks one basic question. Is the battery more than 95% full? If the answer is yes, boom, it flips the switch. It's an automated decision that happens in a split second, way faster and more reliably than any human could ever manage.
So that's how it manages power when it's sitting still. But what happens when the assets are on the move? Well, that brings us to the Foreman's second personality, the supply chain diplomat.
In this mode, the logic is totally different. Instead of watching a battery, the agent is watching a GPS signal. So when a truck carrying the Foreman enters a predefined area, what we call a geofence, say a 5-kilometer radius around a border crossing, it automatically triggers an action. It instantly compiles the entire cargo manifest, digitally signs it, and emails the PDF directly to the customs broker. Now here's the magic. The paperwork arrives before the truck does. Think about that. The result? Potentially zero wait time. No more engines idling for hours on end.
But really, these two missions, they are just scratching the surface. The underlying platform is so versatile, it can be adapted for all kinds of automated jobs.
I mean, just look at the flexibility here. For a smart farm, the trigger could be low soil moisture, which then only activates an irrigation pump at night to reduce evaporation. For a cold chain, a rising fridge temperature could send a critical WhatsApp alert to a manager. It could even take that same excess solar power from our first example and use it to fire up a crypto mining process, literally turning wasted electricity directly into value. This whole idea has a name. It's called edge computing, and it simply means the intelligence, the decision-making brain, lives right there on the machine itself. It doesn't need a constant, stable internet connection to some far-off cloud server. And that independence is what makes it so powerful for remote locations or vehicles on the move, places where internet can be spotty or non-existent. And get this, the entire package, which includes a perpetual software license and that absolutely essential hardware adapter, is a one-time purchase of $299. It's a single investment to give an outpost or a fleet a lifetime of smart automation. And this, right here, is the ultimate goal. Whether it's a farm squeezing every last drop of power from the sun or a logistics fleet that can just glide through borders, the result is the same. You get true operational independence, powered by intelligent automation, right where you need it most. So we've seen how this can work for a solar grid and for a supply chain, but that just opens up a much, much bigger question, doesn't it? What other parts of our physical world, what other machines, are just sitting there, waiting for a brain to make them smarter, more efficient? What else could we automate if every single machine had a foreman?